In this video, I'm going to show you how you can train a pixel classifier in 3D with Napari. So this is an image. We have several channels, but here we're going to focus on the neurites, myelinated neurites. So these are structures that are quite difficult to segment with classical approaches. So we're going to see if we can do a better job with a pixel classifier. So if we go to plugins in napari-accelerated-pixel and object classification, we have something which is semantic segmentation, which is actually what we want to do. Semantic segmentation is actually trying to estimate a class, a label at each pixel or voxel. So here we need to tell which channels we want to use. So we can use several of them if we think that it's going to help. Here we only have as the information in the other images are not useful for that. We're going to just select the myelinated neurites. Okay. Then we can define where we're going to save the classifier. So I'm going to go here on my desktop and I'm going to call it pixel classifier neurites, for example. Okay. And then I need to define the features. So by default, all the features available with this plugin, which are so Gaussian, difference of Gaussian, Laplacian of Gaussian, and Sobel of Gaussian, are selected at scale 1. So when you use different scales, it's very important to keep in mind what you're doing. If I want to extract, to segment tissues, for example, I'm going to use high resolution, maybe a mix between high and low resolution. Sorry, I'm messing up here. This is high resolution because you apply a Gaussian with a small kernel. The larger the kernel is, the blurrier the image is going to be, and it's going to help you identify structures within a larger context. Okay, so if you have low resolution, you're going to have more context, extremely useful when you want to identify tissues. When you have structures like this that are very high resolution, how to explain that? You have structures that you really need to have the most resolution to actually identify this different fibers here. Looks like fibers, neurites. You definitely need high resolution. If you go into low resolution, you're going to blur everything and you won't be able to identify the individual structures here. So very important to have something low, so like 1 should be fine. Okay, you have parameters related to the random forest algorithm that is used. I'm going to keep it the way it is right now. And then you can train. So to train, you need to actually use a label layer in here. And you're going to define several layers. So here, we're going to try to do something very simple. We're going to have objects with label 1 and background with label 2. So I can use the brush. Now it's very important to have a brush size very small. Why is it important? It's because if you have a large brush, so let me show you. Large brush, first of all, I cannot have my structures, but I could use it for background, for example. The problem when you do that is that you have many examples. When you do that, every single pixel that is labeled here is going to be used to train your classifier. So you have lots of pixels here, voxels here, so lots of examples that are all about the same thing. You know, it's like giving lots of examples for one situation. When you do machine learning, it's very important to have very diverse set of training example. And when you do that, you are very prone to do some overfitting. It's because you're going to be very good for this particular region, but whenever you look at other region in your image, but even more in other images, is going to be harder. So I'm going to remove this. And as I said, very important to have brush size. And this is really, whenever you do machine learning based on what we call shadow machine learning, old-time traditional machine learning, it's very important to show examples that are so by using something like this. What it means that here we add this pixels, we have just a few examples, and so it's going to be much better to have several lines like this that's going to be representing different situations than having one big chunk. So I can add something like this to have different neurites. If you want, you can also use the different views, not this, sorry. This here, I'm looking in, so let's say here it's XY, should be XZ and YZ. So you can add example in other direction that might help. For example, here we see a clear structure. So as these features are 3D, it's probably a good idea to add example in the different views like this. And so I'm going to add a few examples so I can just show you. First, if you want to see what it gives, you can train. No ground, sorry. So it tells me that I don't have any annotation that are used for examples. It's because here, select ground truth annotation. So I need to say that the structures I annotated, they are in the labels layer. And now I can train it. And it's going to generate a new layer here. And you have, so the identify structures in brown and the one so in the background. So of course, not great so far, but I only have a few examples. So if you want, you can also use, so in that case, when you have one object of interest, you can select the show selected. It's going to only show me the structures, might be easier to visualize. And so clearly here, it's just saying, just looking for intensity. So I can add, so maybe sometimes it's easier to get rid of it. Make sure you select the right labels. I'm going to add new examples, and I can try to add example with lower intensity as well. So like in here, even though here the resolution is definitely not great. It's going to be a very tough, very difficult task. But here I can, for example, it's going to be helpful to say that this is not a structure and this is not a structure. Let's try to separate different structures. And so then you can add a few examples, train again. And boom. And so here you see as I okay, let me just select this so I can move it. So as I fit the classifier with some example. I can remove this, not useful anymore. Examples in between structure. Now it does a better job at identifying individual structure. Problem is that we have a lot of noise. So I'm going to try to improve this. So I'm going to add more example, and I'll be back with results that seems more reasonable. All right. So I just added a few examples. I don't want to spend too much time because here is really more. The idea is to show you how you can use the tool. This is a very difficult task. Here, it does an interesting job because clearly what is detected here seems to correspond to real structures. We are missing some, so I'm not sensitive enough. We also have, some background noise. Now we can also try to do some post-processing to improve. So we'll see how we can include that in a pipeline with a Napari assistant to see if we can try to improve and get better results.